All right, welcome to the Explainer. The world of cybersecurity just had one of those moments where, everything fundamentally shifts. That future we've all been talking about for years, well, it's here, and it didn't exactly knock politely on the front door.
So let's just sit with this quote for a second. This came from a top security executive reacting to a really groundbreaking new study. For what feels like forever, the idea of an AI that could just go out and hack a network all on its own, that was pure theory. But as he says, the theoretical is now operational. What used to be sci-fi is now a confirmed, real-world thing. And here's why everyone is talking. Researchers at Carnegie Mellon, working with the folks at Anthropic, proved that AI agents can, with absolutely zero human help, plan and carry out some pretty sophisticated cyber attacks. And here's the kicker. In their tests, they had a perfect 100% success rate. So today, that's what we're breaking down, exactly how this new class of attacker works, and maybe more importantly, what the modern playbook looks like to actually stop it. Now, to even begin to think about defense, you first have to understand the opponent. And let's be super clear, this is not just a faster version of the same old threats. No, we're dealing with an entirely new class of attacker. The game has changed. What's really fascinating here isn't just the speed, it's the change in method. A human attacker, right? They work in shifts, they get tired, they get sloppy, they usually go for the big, shiny, high-value target first. The AI attacker, it's completely different. It's tireless, it works 24/7 at machine speed.
But the really crucial part is that it methodically checks every single path. In one test, it found some credentials and then just used them to access all 48 databases in the network, not just the one a human might have aimed for. It's a game of total, relentless, systematic exploitation. So, how? How did this AI get a perfect score? Did it invent some brand new, never-before-seen super exploit? Not even close. It turns out it simply followed a playbook that we wrote for it with our own security failures. And this right here is the absolute core truth of this whole thing. The AI won by using old, predictable security gaps. It used known vulnerabilities in environments that were modeled after huge, real-world breaches like the Equifax hack from 2017. So this wasn't magic. It was just a masterful, brutally efficient execution of connecting the dots that we left lying around for it. So the researchers boiled it down to 5 fundamental weak links that gave the AI its opening. And these aren't just separate problems, they're like a chain reaction. You've got predictable systems with known bugs, that's the front door. Then you have a lack of machine speed detection, which lets the AI sneak around unseen. But the real damage, the thing that turns a small problem into a huge one, is that third one, inadequate identity and access control, because that is where the AI found the keys to the kingdom. So before we go any further, let's make sure we're on the same page about this term, privileged access. Just think of these as the master keys, the admin accounts for your entire organization. They give you sweeping, deep control over your most important systems and data. In the wrong hands, it's catastrophic. And that's exactly it. The AI found a superhighway built out of these keys. It went after what we call over-permissioned accounts, accounts that have these static, always-on passwords and way more access than they actually need to do their job. This is a classic, textbook security failure, and it's precisely the problem that a modern, unified privileged access management platform, or PAM, is built to solve. By doing things like enforcing least privilege and just-in-time access, these systems basically tear up those superhighways before any attacker, human or AI, can get on them. And believe me, the cost of getting this wrong is just staggering. According to IBM, a data breach that involves this kind of unmonitored shadow AI costs, on average, an extra $670,000. Think about that. That's like adding the price of a brand new Ferrari to every single data breach. This isn't just a technical problem, it's a massive financial liability waiting to happen. Okay, so that's the threat. It's fast, it's relentless, and it absolutely loves to exploit our oldest and dumbest mistakes. So, how do we possibly fight back? Let's get into the modern defense playbook and see what the human counterplay looks like. Security experts have laid out 3 core pillars here. First, you have to automate your controls. You can't have a human clicking approve when the attack is happening in milliseconds. You need systems that block threats automatically. Second, you have to fight fire with fire, or in this case, fight AI with AI. Your defenses have to see and react at the same sub-second speed as the attack. And third, you need unified visibility. AI attackers thrive in the dark corners, the blind spots between all your different tools. A consolidated security platform, like a modern PAM system that sees and controls all that privileged activity from one place, is what gives you that single pane of glass to get rid of those shadows. And all of these pillars, they're built on one single foundational principle: zero trust. It's a really simple but incredibly powerful idea. Never trust, always verify. Instead of handing out those broad, static permissions that are always on, a zero trust approach validates every single access attempt every single time. It directly attacks the problem of those over-permissioned accounts that the AI hacker just loved to exploit. It's an absolutely critical strategy for this new world. But, okay, before we all start bowing down to our new machine overlords, let's inject a serious dose of reality here. This AI attacker, as powerful as it is far from perfect. In fact, right now, it's deeply, deeply flawed. So get this. In another study from Carnegie Mellon, when you give these same AI agents complex, multi-step tasks, the kind of stuff you'd actually do in an office, they fail about 70% of the time. That's right, they fail most of the time. And why is that? Because while they're amazing at narrow, predictable tasks like finding a known vulnerability, they completely fall apart when they run into ambiguity or need real-world context. I love this quote from a developer because it just perfectly nails it. Autocorrect on steroids. You might have heard people call it spicy autocorrect. The point is, these models are not thinking. They're not reasoning like a person does. They are incredibly sophisticated pattern-matching machines. They are just predicting the next most likely word, or in this case, the next most likely step in a cyber attack. And that leads to some really serious limitations. They're famous for hallucinating, which is just a nice way of saying they make things up. They're often better at sounding correct than being correct. They'll confidently suggest code that doesn't exist or state things that are just plain wrong. And this is why, for now at least, they absolutely require a human in the loop to double-check their work and to separate the facts from the fiction. So that brings us to the big final question, doesn't it? We're facing this new attacker that is both relentless and autonomous, but also kind of brittle and prone to making stuff up. It operates with terrifying machine speed efficiency, but it does it all without any genuine understanding. So the real challenge for us isn't just to build higher walls, it's to build smarter defenses that can actually exploit the fundamental flaws of a machine that doesn't truly think. That is the new game we all have to figure out how to play.